Okay, sure. So yeah, look, I've been with iGlobe now since 2015. That's going on 8 years, I guess. It's been a wonderful journey thus far. Um, Essentially, I've always sort of been part of the survey world.
Yeah.
So that's where I found myself. I was lucky enough or fortunate enough to work for two of the biggest geophysical exploration companies in the country.
Okay.
And that meant that I could travel all over the Africa and the Middle East, and learning a lot of sort of operational skills within the field. But not only from an operational point of view, but then also from a technical point of view to understand specifically from airborne geophysics and airborne survey, the things that are required, the fundamentals that are required in order to execute a successful survey project.
Yeah.
So I was actually headhunted by iGlobe in 2015 to come and join their company. At that point, iGlobe was already a front runner in the market in terms of geospatial solutions and specifically geographical informational systems. And in 2015, as most people know, that was sort of when the Part 101 drone regulations were promulgated in South Africa. And I think because of my experience both in aviation and in survey, it was just a good fit to then come in at that point and sort of start up the aviation side, the regulated aviation side of iGlobe's ROC. Well, it's illegal to operate drones commercially in South Africa at this point. So South Africa, a lot of people give the civil aviation quite a lot of flack for the way that they've set up the regulations, in that they're very robust. And, it's quite a tedious process to get yourself the various licenses. But what people forget is that South Africa were, in fact, the first ones to release regulations in 2015. And the rest of the countries actually just followed suit. This does not mean that there are shortcomings or maybe sometimes, a over-regulated space in the drone industry. But I think we've got a lot to be thankful for in terms of the CEA and what they've done for us. And so, yes, the long and short of it is, in order to operate commercially, you need to have an operating certificate. And underneath that operating certificate, there's a number of other sort of requirements as well. So, for example, you need to have an air service license that's been approved by the Department of Transport. You need to have various post holders in strategic positions that have got specific aviation courses and aviation experience and qualifications. And then obviously your pilots also need to have remote pilot license, again, approved by the CEA. Not at all. So yes, there's certainly countries that where the process is a lot simpler. But to become a drone pilot is much the same as becoming a manned pilot. So in that, you've got a set of theory exams that you have to do.
Yeah.
The theory exams are a lot more condensed than manned aviation, but yet they are still critical and important to unmanned operations. And once you've completed your theory, you'll then go over to your practical component. And it is at this point where you'll decide whether you're going to be a multi-rotor pilot or you're going to be a fixed-wing pilot, or both. And thereafter, there's also additional courses that you can load onto that. So, for example, if you want to do crop spraying, you'll need to get a PCO license. There are beyond visual line of sight licenses, or BVLOS license, and then also night flying, etc. and so on. So there's also, again, the same as manned aviation, there's certain ratings that you can put onto your license. To answer your question in the difficulty, though, look, if you wanted to become a drone pilot tomorrow and you've got the money at hand, you probably need around, I'd say, 25 to 30,000 rand, and you'll be able to become a drone pilot in 3 weeks.
Okay.
If you have the time available. So at the moment in South Africa, again, in order to train pilots, you need to have what they call an ATO, which is an approved training organization from the CA. And we've got a number of schools in every single province in the country now. So that, the options are, there are quite a lot of options for students wanting to go that way. Yeah, so I really like the term intelligent data acquisition. It's a term that explains what we do quite well, a certain component of what we do. It's always been said that, what iGlobe's involved in is the solutions and actually the meat of the data and how that is visualized. However, it's also important to look at how the data is collected.
Yeah.
And any sort of GIS system or any sort of geospatial data management system requires up-to-date data.
Yeah.
So data that's firstly up-to-date and data that's accurate. Now, how that data is collected by various means. We've just had a conversation with regards to drones. Drones, when they hit the market, or when they became commercially viable to use as a data acquisition piece of equipment,
Yeah.
has really done well. But they're not the only one. And it's something that people often have to remember, that it's not a one-size-fits-all kind of approach. It's really a horses for courses. What data you're trying to collect, what is the extent of it, what's the difficulty, and then most importantly, what is the outcome? What is the outcome you're looking for, and what are the deliverables? So drones are just one of them. But then we can also look at things like normal GPS, conventional GPS,
Yeah.
rover and bases. We can look at laser scanners. We can look at unmanned bathymetric boats or bathymetric vessels. There would be IoT sensors. There's a number of things that we actually use. I mean, water level sensors, air pollution sensors, etc., etc. So what we call intelligent data acquisition, what makes it intelligent, because these are now all the different acquisition equipment, but what makes it intelligent is how we integrate them with each other.
Okay.
And I think that's something that's becoming a lot more prevalent and a lot more important in the market today, is that we've got all of this cool technology that's sitting out on these various sites, and they're all publishing to their own respective sort of platforms, which we often feel is you're missing the point. And that is what the business that we're trying to be in is, to say that we want to integrate all of these acquisition methodologies into one central platform, where, more intense data interrogation can occur, and where there is, sort of a one-stop shop, if you would say that. And that, again, pushes towards, deriving that digital twin. To have all of those data's integrated into one. So, look, I think each one in their own respective way has got their own specific benefits. I think, once again, if you look at the invention, and a lot of people don't know that, but the normal GPS and rover is actually not a very old technology. It's actually still quite new. But how that has changed the surveyor's life is amazing. And now sort of putting a GPS on a drone, that's changed it even more.
Yeah.
So in any industry, but particularly focusing on oil and gas and mining, time has now become the currency, and not actually money. And this is what all these sort of platforms are trying to achieve. I actually ran a poll recently on LinkedIn where I asked my network, listen, specifically I'm talking about drones. What do you think what does the client look for first when they are trying to set up a drone program, or they are selecting a drone service provider?
Yeah.
And the options that I've given is turnaround time, price, or data accuracy.
Yeah.
And working on this side of industry, it would obviously be price, because you always want to get your price right.
Understood, yeah.
But the poll's feedback was actually mostly turnaround time. So turnaround time seems to be a lot more important for industry than accuracy. Not that accuracy is not important. Accuracy is incredibly important. But because you've got a much quicker turnaround time, you've also got much more time to ensure that your product can be a lot more accurate. So you've got a lot more time for R&D. You've got a lot more time to interrogate the data. And if the data is not at a standard where it should be, you've still got that time to go conduct the acquisition in a different methodology.
So if you've got a good turnaround time, does that imply that your downtime will be lower as well?
100%. So if we take, for example, inspecting a cooling tower as an example, the traditional or conventional way of inspecting these cooling towers is that they'll have guys with rope axes going up and down the towers.
Yeah.
So immediately that screams a massive safety risk. Firstly, and then secondly, time and costing. So the downtime of a cooling tower, costs that particular site a hell of a lot of money per day.
Yeah.
Now, if you can lessen that downtime from rope access from 3 weeks to effectively a day, the cost saving, that's your business case already written effectively.
Yeah.
So that the cost saving is enormous. So turnaround time it always will result in cost savings. Look, I think it's difficult to put it into a number, but there was a study that I read recently as well, an article that I'd read that of all the different cases where drones can be put in harm's way, if that were to say, where people no longer have to be.
Yes.
So these would be areas for open cast mining, for example, where they start doing all the blast monitoring and the blast video, post video processing and so on with drones. So before they actually conduct that, before they actually set off the blast, a drone can actually fly around the area with thermal technology, or with a drone fitted with AI to make sure that everybody is out of the pit.
Yeah.
Okay, so that's just an extra step you can take. Then talking again like we did with the cooling towers, there is a certain risk that's associated with it when you're doing it with rope access, or if you're doing smaller structures, even where you are doing it via cherry picker or scaffolding. There is now effectively, 20 staff per inspection that is no longer required where a drone can do it.
Yeah.
So it's taking people out of harm's way. And that, that goes from the surveillance point of view, where you don't need so many more guards on foot carrying firearms and fighting fire with fire. You'll actually have a drone in the air to make sure that you get the right people at the right point at the right time. So there's a lot of ways that drones have definitely made the workplace safer.
Yeah.
The only way to really do it is to learn and learn and learn and learn. I think we will be the first ones to say that we're humble enough to say that we've certainly failed many times in terms of what we thought the outcome would be. But the homework has been there. And again, it's always important to look at the deliverable and the outcome you want, and then work backwards from that, rather than saying, okay, you're going to go fly willy-nilly, see what kind of data you get from the drone, and then try and let the guys in the office work their magic. It doesn't work that way. And unfortunately, what it does take is a lot of time, a lot of commitment to say that you will fly a single structure over and over and over and over again to make sure you get to this product where you start hitting the sweet spot. Now, look, once you've got that methodology, then it becomes repeatable. And repeatable is obviously very nice, I guess, from an operational point of view, but it's also very important to have repeatable flight missions in order to maintain the integrity of your data, to make sure that everything's always done the same way, and to make sure nothing falls through the cracks. You never inspect a structure, whether it be a cooling tower or cell phone tower or silo, whatever it may be. You never inspect it only once.
Yeah.
You need to inspect it multiple times before you can start developing trends, before you can start sending out preventative measures, and so that you can start doing your planning accordingly. And in order for you to compare those two data sets, it's very important that they're done in the same way.
I see.
If you are not using the same parameters, whether it be from the equipment or from the software side, then it becomes very difficult to compare the two. Then it starts becoming like comparing apples and pears.
I see. So it needs to be comparable, reliable, and consistent.
That's it. Look, so again, as a company, what we're striving to is the digital twin. Okay, now digital twin is a term that's been used quite a lot lately. It's aligned very closely to the whole idea of the fourth industrial revolution, which I think we're well into already. And digitization as a concept is certainly not a new concept, but then sort of intelligent digital twins is now becoming more to the fore. So a client needs to be, for them to have a return on investment in saying that they're either going to invest in a drone program themselves or other acquisition techniques themselves, or they are going to use a service provider, you need to be able to show to them what are they going to save by doing this. Okay, so there's a big difference. Which I've definitely found in the market is to say that for example, in the agricultural industry, they don't want you to tell them how you're going to save them money. They want to tell you how you're going to make them money.
I see.
Whereas obviously in the mining and oil and gas industry, it's always about, listen, let's see how we're going to save money. Because if you save us time, is invariably we're going to make more money, and invariably we are going to save money.
Yeah.
So in order to provide them with that insight in the business case and in terms of how they're going to have a return on investment, we need to first identify the problem. Okay, so once you've identified the problem, you can associate a solution with it. Now, the problem could be anything in terms of saying, you know, we've got a vessel that's always leaking from a certain point. We want to establish why.
Yeah.
And we use various different techniques to try and ascertain where that leak is coming from. Or it might be that we're just going to save them time on a certain project because this type of acquisition methodology will conduct the inspection a lot quicker.
I see.
So there's various ways of conducting the business case. But it sort of becomes, at the end of the day, it becomes a no-brainer for industry to start adapting techniques that are A, going to save time, and B, that are going to be a lot more accurate. You know, specifically if you're looking at cooling tower inspections, and for that matter, sulfur tower inspections. I mean, the conventional way of guys climbing up there with clipboards, number one, we've already spoken about the fact that it takes too long. We've already spoken about the fact that it's not safe. But we haven't spoken about it's not accurate either. Because if you're just going up there with a clipboard, humans do make mistakes. Humans do not see everything. But if you can have now this asset in a 3D model that can rotate, that is geographically referenced, and where you've started using artificial intelligence techniques to identify defects, you start getting a bit more holistic approach of a holistic view of the asset, which humans can't mess up, essentially. They often don't know how much information they can pull from these assets. For example, if you were to go do a cell phone tower because they would like to see, the property guys would like to see whose assets are currently on their tower because they have lost their asset registry. You know, are the various suppliers that are on their tower paying their rent for using the tower and so on. So you create a very rich 3D model from that, and from that 3D model you extract a CAD drawing, and from the CAD drawing you can now have an asset registry.
Yeah.
But then now when the other departments start looking at this 3D model, then, you know, the civil engineers might say, listen, I know you've done this from a property point of view, but we would like to look at this from an engineering point of view, because we can now actually see that there is some rusting on this facility, or we can now see that there are missing bolts or missing members or whatever it may be. And they would like to extract that information as well.
Yeah.
You know, then you would have, for example, the logistics guys having a look and saying, listen, we can actually see from this 3D model that the access road or the fencing around this is completely messed up.
Yeah.
You know, so because you're not only looking at one thing and that's all they document when they're inspecting it, you're now inspecting the asset as a whole. There's a lot more different stakeholders that can now seek benefit from this.
I see.
Okay, well, I think, again, the easiest would be to use an example. So if we had to use a tailing stand, for example. So currently we're conducting aerial and bathymetric surveys of tailings dams on a weekly basis, you know, and these tailings dams range from between 50 to about 250 hectares, and we do multiple of them every week. Now, if we say how is that done in conventional ways? So back in the day, what they would then do is you'd have, well, firstly, to get a snapshot, you would have either the Surveyor General's images that's been flown with fixed wing aircraft. The chances that they've come over your area is usually in between, 4 to 6 years old back then. So you don't have very accurate data. So you've got an idea, but it's not very accurate.
Yeah.
Or you could use satellite data, again, which is not accurate at all. Well, for those purposes, at least, Google Earth has certainly got a lot better. And again, not too up to date. So, and so that's from a snapshot point of view. And actual, from a survey point of view, you would have surveyors walking around the berms, walking around the walls, and measuring various kinds of facets and measuring various kinds of parameters. And that only gave you really, very limited information which pertain to, where the lowest points are, where the spillway points are, what the runoff could be, and also you could go and measure the water level on a once a week basis.
I see.
So And in order to conduct the whole survey, you'd probably survey the whole tailings facility in those sizes that I was just speaking about for 100 hectares. The guys would be surveying for a week on all these various aspects just with the GPS. However, now we sit in the luxury where we can essentially incorporate 3 different data acquisition techniques. So firstly, we've got a water level sensor that sits on the facility permanently. Now that water level sensor publishes straight to the dashboard, to the sort of tailings management dashboard. Then we also conduct aerial and hydro surveys, but we conduct those on the same day at the same time. So now you've got a terrain that is built up from the aerial image. You've got a very dense terrain, a very dense mesh that's been built up of the terrain. And then you've got a very dense mesh that's been built up from the bathymetric survey.
Yeah.
You now combine these 2 meshes, and then you've got effectively a very dense XYZ file of the entire facility. So you've got a point cloud of not only the depth, but also the surface of the facility. So now once you've got that information, there's a hell of a lot that you can do with it. You can start saying, okay, listen, how is this facility reacting towards what the legal freeboard is that's been put down by government, what the internal freeboard is, what, sort of their each site's specific limitations of the facilities are, and then how that plays in relation. So, because we've got a live water level, we're able to tell them, okay, listen, this is how much space you've still got available in the facility, or this is how much you need to remove.
Yeah.
We can also now start saying predictions, because we know exactly how much water is in that specific facility and how much it can hold. We can then say, if your water level had to rise by 10 centimeters, that would equate to this much in water covering by area in square meterage, and it would equate to this much in megaliters of water.
Okay.
So you can now then build up a very good database of predictions, and then without actually having to go out to do another survey, because you've got a remote water level sensor sitting there, if that water level changes, it will automatically update the parameters of what is required in that facility. So where we are striving to get towards is to say that we do not want to give you an answer of what's happening on your tailings facility once every 2 months, once every 6 months, or whatever it may be.
Yeah.
You must have an answer every minute of every day.
Yeah.
And that goes back to the saying a digital twin or reality modeling, to say that what you're seeing on your PC now is what's happening outside in reality. You're not looking at data from months previously.
That's insane.
And that's how it's changed from the conventional ways. So again, specifically on tailings dam, our biggest focus there is safety. It's every single organization that we work with, and obviously we work with some of the big boys, not only in South Africa, but Southern Africa, Dubai, United States, and so on. And these larger companies are always incredibly sensitive of what happens with their data.
Yes.
It's for us very important as well that our data doesn't get leaked. So that's why our systems are governed by a number of ISO-rated data security protocols. For example, our data management dashboards are all governed by specific AWS or Amazon Web Services protocols. And our data is always also encrypted. So no data gets streamed over any open GSM service. Everything is in closed services that publishes to our dashboards. So security is one of our, definitely something that we take a lot of pride in that our solutions are very secure. And again, it's also how you interpolate the data. Nobody is concerned about the raw data that's been collected from an acquisition point of view.
Yeah.
So, you might have a terabyte of data that you've collected in a week's time, but the answers that you're going to give is eventually just 2 or 3 PDFs. And it's that data that needs to be secure.
Yeah.
I think iGlobe has certainly managed to reap the benefits of using these various tools. Specifically on the drone front, we never ever saw ourselves as wanting to be in the forefront or one of the front runners in the country when it comes to drone services. We were focused always primarily on the data, but because we wanted the data stronger, we had to increase the kind of drones we use, the payloads that we use. And for that reason, we have now become one of the sort of front runners, not only when it comes to acquisition, but not only when it comes to the equipment we use, but also when we actually go and inspect, and the way that we inspect, and the way that we sort of collect data on many different levels, from many different industries. We've also been fortunate enough, to guide other clients on their success journeys. So one of the things that we did do in 2015, from about 2015 when we started in the drone exercise, to say that, look, we don't actually want to operate the drones. We want to upskill the clients so that they can use the drones, and we want to work with their data.
Yeah.
And there are 2 or 3 prolific mining companies in the country which we then supplied with drones. Some of them that we actually manufactured ourselves specifically for the purposes that they had.
Oh, that's amazing, yeah.
And then took them through the whole process of saying, okay, listen, the flying of the drone of those. So, for example, you're going to fly a stockpile.
Yeah.
The flying of a drone is, 10% of that whole process. So we need to start moving away, to try and move their mind shifts away from saying, okay, listen, the drone is the begin all and end all of the process. A very good understanding of how to lay down your ground control points, and very good understanding about mission planning is required. After the drone flight, a very good understanding of data processing, and then report writing is, executing of the reporting is important. So we would then set up training programs to run them through all of those steps. And there's a few of those mines that are still operating on their own today. We still help them occasionally when they've got hiccups. But they've certainly also reaped the benefits of saying that, instead of spending 3 or 4 days on their stockpiles measuring and walking them with GPS backpacks and so on, they're now doing, all of their stockpiles in a morning.
Oh, that's amazing.
Which is always good to see. It's always good to see that you've made life easier for you.
Yeah.
Sure. Yeah. Look, I think there's massive changes coming. I think if you just have to look at what's happening in the last, never mind 5 years, let's look at what happened in the last 3 years or the last 2 years, how things have just sort of blown up. I think it now sort of becomes difficult to see where the end of this is going to be. I don't. Perhaps that's not the right way of saying it. It's not difficult to see. It's actually difficult to contain your mind to see what is going to be possible. I think there's a lot of technologies now that we look at now. For example, drones even, that we think are, the most amazing things ever. But the way that, Elon Musk and his cronies are sending satellites up into the sky, things like topographical surveys, things like remote sensing and so on, that will start becoming obsolete with drones. And drones will specifically be focused on asset and infrastructure inspections.
I see.
I think that's where drones can still get a lot better. And I'll touch on that a little bit more now. But I think from sort of conventional things that drones are doing now, a lot of that will fall away because technology is just increasing too quickly, and there's better ways of doing things, or easier way of doing things, So when it comes to the infrastructure inspections, drones are now also starting to do a lot more in terms of just saying that, okay, we've got a LiDAR sensor on it, or we've got a infrared sensor or a camera.
Yeah.
They're now actually fitting equipment to drones that can now start doing, a little bit more NDC testing, so non-destructive testings and so on. So you can start measuring steel thickness and all of these other kinds of things. They're putting sensors on where you can start detecting gas leaks and all of these kind of things. I think those kind of the payloads that go onto drones are just going to, get exponentially better. The drones themselves, I think, have sort of hit the limit. So you can obviously. There'll still be the big guys like DJI and so on. They'll still be pushing, the normal things: longer flight time, better batteries, more payload capacity, takeoff weight and so on. That will always be pushed. But from a payload point of view, that's where a lot of more attention is into now. So, I think we're just sort of on the cusp of it at the moment. And I think it's going to be amazing to see what the future holds. And that's just from the drone side of things.
Yeah.
Just in the past 2 years, we've learned a hell of a lot more about remote sensors, so water level sensors, whether they be barometric or water line sensors. So you get the visual sensors, and then you also get the pressure or barometric sensors.
Yeah.
There's air quality sensors. There's, we can now remotely tie into our remote system. We can tie in piezometers and moisture sensors and all of these different kinds of things. So I think, payloads and sensors is where the push is coming from, going towards the future now. Intelligent data acquisition is a phrase that's been coined by iGlobe effectively, and like I say, it's basically a phrase that encompasses many other techniques. So not only different kinds of equipments, but different kinds of techniques within those equipments.
Yeah.
And there's often solutions that require where it doesn't require a drone, for example, and then you need to come up with something else.
Yeah.
Whether it's going to be a terrestrial laser scanner, or whether it's going to be a handheld device. For many of our inspection modules, we've got an inspection application that goes onto a cell phone. So essentially, a cell phone also falls into that bracket. So anything that collects data falls underneath that bracket. I think, obviously, certainly, drones are a big part of that. But they're just another tool in the toolbox that we use to push and get these solutions at the point where they should be, which is incredibly accurate and, more importantly, incredibly up to date all the time.